great individual. Anyhow, it goes into the air intake on here. Now, one of the key things that you want to do is to make sure that when you put it into your air intake, that it is prior to the vacuum piece for your engine. Reason being, when you increase the speed of your engine, you create more of a vacuum. The more vacuum that you're using here, the more hydrogen that you want to be sucked into the engine. That's what's going to maintain your fuel mileage on here. So make sure it's prior to the vacuum so that the engine can suck in as much as it wants when it wants. That's the whole purpose behind hydrogen on demand. Okay, let's get into the electronics real quick. From the switch that I have in here, okay, that switch is powered. This is my fuse box up in the engine. I have it on this little 15 amp fuse. I don't know if you can see that real well. I have it on that 15 amp fuse. That 15 amp fuse is one of the fuses used for my fuel injection. That way, the only time that power is actually going to leave this line is if the engine is running. The only way that the fuel injectors are going to get power is if the engine's running. So I've got this running from the fuel injectors to that switch. When it comes back, it goes to this. This is a 100 amp relay. So this, when that switch is off, it'll stop the power going from here to here, which shuts the system down. Okay? So that's a safety precaution to make sure that even if the vehicle is running, I want to shut the HHO off. All I got to do is hit that switch and it shuts it off pretty much completely. Now, on the relay, what you can do, or what you need to do, is on the second one here, this is a negative. So I've got that running straight over here to the negative on the battery. Alright, the power that's going to the relay, I have a line going straight off the alternator to a 60 amp fuse right here. And you can see that this is a fuse. I can hit the reset switch and reset the fuse. The fuse is then putting the power directly into the relay. The only time that this relay is going to allow power to go from this terminal to this terminal is when that switch is on, or when the relay kicks over, or when the engine is running for the fuel injectors, which turns these on, which is a switch that allows the power to flow through. This side of the relay is going straight down to the hydrogen processor down there. The negative side coming off the hydrogen processor is also coming back up. You see I got my two wires here. One's negative, one's positive. One's going right to here, which is the positive. The negative comes over here to what's called a pulse width modulator. This kind of, I don't know if I can explain this real well to you. This kind of sends a jiggling volt or amperage to the hydrogen processor, so that's kind of like zzz, like this. That's why it's called a pulse width modulator. It helps the hydrogen unit down there produce hydrogen on a much larger scale and much more efficiently. Now this is a very nice unit because this you can actually set the amount of amperage that you want for running to the hydrogen unit. The less amperage that you're using, the less hydrogen is going to be produced. The more amperage that you're running, the more hydrogen is going to be produced. But the higher amperage that you use will also cause this water that you're using up here to get hotter. And you don't want this too hot because steam is not hydrogen. So you want this to stay reasonably cool. You don't want it real hot. So you don't want this like at 45 amps or anything like that. You want to be reasonable about it. And you may have to test yours like I did with mine. I had to test mine for 3 or 4 days to find what was perfect for my vehicle, which happens to be roughly 28 amps coming off from this. Now, this thing on the negative side, like I said, runs down to the hydrogen unit down there. The negative side to this is running over to the frame of the truck. So this is actually just the negative side of the whole system. Okay, from here, let's see, what else can I explain to you? Oh, to power this up, I've also got it tied into the same wiring going into the fuel injector here. So this will not power up without the engine running or the switch on. And the switch can't go on. You can turn the switch on all you want, but it won't fire up without the engine running because it's drawing its power from the fuel injector. So, just so you know, I had to cut little spots in the plastic here and here in order to get this through here. So you may have to do a little bit of light modifications to your vehicle, like with the plastic, just to get things to work right for you. So you can fit the wiring. Anyhow, as you can see, the switch is off right now. Okay? There's no light on it. I start the vehicle up, it's still off. Okay? With it off, we go up here and we look. You'll see I have a small amount of amperage here, about 1 amp. That's because the power that I'm drawing off from the fuel injectors is running into here. Okay, because remember we tied it in right there, so it is running into here. So it is getting a small amount of power. It's actually about 5. I believe it's about 5 volts is all it's getting.